So in this problem, we're given that there is a supergun that shoots bullets off at some initial speed v0, and we're not given what the angle theta is that it shoots them at, but there must be some angle theta. And we're given the maximum range, L, of the supergun. And what we're asked is to find what v0 must be in order to achieve that maximum range. Now the way we're going to go about calculating this is first we're going to split v0 up into its component vectors. So that's going to be v0 cosine theta x hat plus v0 sine theta y hat. And the reason we're doing this is because this is going to allow us to calculate the time that the bullet spends in the air. And the reason that lets us do that is because the acceleration on the bullet is only acceleration due to gravity, which means it's going to take this parabolic curve where the only component that's changing is this v0 sine theta in the vertical direction. So that tells us that the total time t that the bullet spends in the air is v0 sine theta over 2, or v0 sine theta over g, times 2. And that's because it takes v0 sine theta over g to reach this point at which the velocity is entirely horizontal, and then because this curve is symmetric, it takes the same amount of time to come back down. Now because g is accelerating the bullet only in the vertical direction, v0 cosine theta is going to be constant throughout its flight. And that means that d, the distance traveled by the bullet, is just going to be v0 cosine theta times t, which comes out to 2 v0 squared over g sine theta cosine theta. And now what we're going to do is we're going to say that since we don't know what theta is, we're going to find what theta must be in order to maximize d for any given v0. So what the ideal angle is so that the range will be maximized. And the way we're going to do that is we're going to use a nice little trig identity here, which is that 2 sine theta cosine theta equals sine of 2 theta. So that gives us d equals v0 squared over g times sine of 2 theta. And since we know that theta is a maximum at 1, which happens at sine of pi over 2, that means that the ideal angle theta, which gives us d max, is going to have to be pi over 4. And that gives us d max equals v0 squared over g at theta equals pi over 4. And so now what we have to do is we say that if d max is v0 squared over g, then v min is the square root of g times d, because v can only get as small as will be allowed by this maximum distance that that initial velocity can reach. So this tells us that if we approximate g to be about 10 meters per second squared, v naught min is the square root of 10 meters per second squared times 1,000 kilometers, which is what we're told is the maximum range of this gun, which comes out to be the square root of 10 to the 7th meters squared per second squared, which is about 3,160 meters per second, or 3.16 kilometers per second. Now in part B, we're asked what the maximum altitude of this bullet is. And again, what we're going to do is we're going to calculate the time t, and then do some math with the vertical velocity. So in this case, we're going to use little t to indicate the amount of time that it takes for the bullet to get from here to here, because this is where the maximum altitude is. And that's just going to be big T over 2, which is v naught sine theta over g. And remember, that's because that's the amount of time that it takes for g to decelerate the vertical component all the way down to 0, because that's where the horizontal velocity is. There is no vertical velocity at that point. And so now, since g is constant, all we have to do is we have to find the average velocity over that time, v bar, which is just v naught sine theta, the initial velocity, divided by 2. And that tells us that h equals v bar times t equals v naught squared sine squared theta over 2g. And so since we know that theta is pi over 4, that means that sine of theta is 1 over the square root of 2, and sine squared of theta is just 1 over 2, which gives us v naught squared over 4g. And since we know that V naught is the square root of g times d. That gives us gd over 4g, or just d over 4, which is 250 meters.